What's up, team? Quick question before we start. Do you actually know MCP servers, managed, external, and custom integration? By the end of this video, you will. Let's dive in. You have a vector search index sitting inside Databricks and a partner's API behind a key they emailed you last week. The same agent needs both. By the end of this video, you'll know exactly which of the 3 MCP server types to reach for in each case, and where the credential lives so the agent passes a security review. We've covered how agents reason and how they deploy. Today is about the missing middle, how they actually reach the tools and data that live outside themselves. 2 terms to pin down before we go further. MCP, the Model Context Protocol, is the open standard for connecting agents to external tools and data. Databricks exposes it over streamable HTTP, and the Unity Catalog HTTP connection is the credential vault behind external MCP. It holds the host, the path, and the secret. The other terms in this video will land as they come up. Here's DataDino's situation in concrete terms. The research agent needs 2 tools. The first is the curated Museum Knowledge Index, which already lives in Mosaic AI vector search inside Unity Catalog. The second is a partner museum's licensed REST API, gated behind an API key the partner sent over email. Same agent, 2 completely different connection problems. The wiring you choose for each one is exactly what a security review will dig into. Before we go further, let's pin down what MCP actually is. It's an open standard, not a Databricks invention, that gives agents a uniform way to reach external tools and data over HTTP. Think of it as the wall socket. The agent has one plug shape, and any compliant tool server can be on the other end. That uniformity is what lets Databricks offer 3 flavors of server without changing your agent code one bit. Notice the docs list 4 things, not 1. Tools are functions the agent can call, like a Unity Catalog function that queries a table. Resources are read-only context the agent can pull in, like a document or a schema definition. And prompts are reusable templates the server offers up. For DataDino's case today, we're focused on tools, but knowing the server can also serve resources and prompts is why the same MCP endpoint can grow with the agent. You don't switch protocols when you add a document store later. Here's a distinction that gets conflated in real architectures. The agent framework, responses agent, chat agent, lang graph from episode 11, decides which tool to call next. That lives inside your model code, and it shapes how the language model reasons. MCP decides something completely different. It decides where the tools come from and how the agent reaches them. That lives behind an HTTP URL. 2 independent layers. Different problems, different answers. This is the mental model to lock in. Swap responses agent for lang graph. Your MCP URLs do not change. Swap a managed MCP server for a custom one. Your framework code does not change. They move independently. When a question swaps the framework to fix a tool problem, or swaps the MCP type to fix a reasoning problem, you can rule it out immediately. Databricks gives you exactly 3 flavors of MCP server, and they cover 3 different ownership stories. Managed servers are Databricks hosted. They front Unity Catalog assets like vector search, Genie spaces, Databricks SQL, and UC functions, and permissions flow through Unity Catalog grants. External servers point at third-party services like Glean, GitHub, Google Drive, and SharePoint, with credentials held inside a UC HTTP connection. Custom servers are ones you build yourself, hosted as Databricks Apps and permissioned by can_USS on the app. We're going to take each one in turn. Here's a picture that makes the 3 types stick. Think of a hotel. The managed MCP is the in-house concierge, already on payroll, knows every floor, no paperwork. The external MCP is the partner taxi service. The front desk holds the account number, and they book the ride for you without ever showing you the credit card. The custom MCP is the private driver you hired yourself, your car, your rules, but the hotel only lets people with a CAN_USE keycard climb in. The question that picks between them is always the same. Who owns the credential, and where does the trust boundary sit? Let's start with Managed MCP, because it's the default, and on the exam, the right answer more often than not. Databricks hosts the server for you. There's no infrastructure to stand up, no token to rotate, no credentials to plumb through. It exposes 4 kinds of Unity Catalog assets as agent tools: Mosaic AI vector search indexes, Genie spaces, Databricks SQL, and UC functions. Every call gets checked against the caller's Unity Catalog grants automatically. The rule of thumb is simple. If the tool already lives in Unity Catalog, Managed MCP is the answer. Every Managed MCP server lives under the same path prefix on your workspace, /API/2.0/MCP. After that prefix, you get 1 segment per asset type. Functions takes a catalog and schema. AI search takes a catalog, a schema, and the index name as a 3rd segment. That's the current form. You'll still see the legacy vector search prefix in older code, and it keeps working for backwards compatibility, but new work should use a DI search. Genie takes a space identifier, and SQL is workspace scoped, no extra path. Memorize that prefix. The moment you see it on an exam question, you know you're looking at Managed MCP. Reading these URLs is like reading a mailroom label. /MCP tells you the building, the Managed MCP service. /functions tells you the floor, Unity Catalog functions, and the last 2 segments, prod/billing, tell you the exact mailbox, the schema named billing inside the catalog named prod. Once you can read the label, you know exactly which tools are inside without opening anything. One detail that catches people: managed servers are schema scoped, not tool scoped. A single URL pointed at prod.billing exposes every UC function in that schema as an agent tool. You don't register them one at a time. Add a new function to the schema tomorrow and the agent picks it up on the next call. Vector search works the same way. 1 URL per catalog and schema pair. Genie scopes by space identifier, and SQL scopes to the whole workspace. The scoping unit changes, but the pattern is identical. Now external MCP. This is where Databricks proxies a third-party service for you, routing the request through a Unity Catalog HTTP connection. There are pre-built providers ready to go: Glean, GitHub, Google Drive, SharePoint, Atlassian. The UC connection holds the credential, either OAuth tokens or a static bearer token. The crucial property is that your agent never touches the raw secret. Databricks injects it at the proxy boundary, so the credential lives in governed Unity Catalog, not in your repo. Straight from the Databricks docs, external MCP servers use Unity Catalog connections with managed OAuth to securely handle authentication without exposing credentials to end users. That last clause is the whole point. End users and end agents never see the token. The proxy is the trust boundary, and Unity Catalog is where the credential is governed and audited. Picture the flow. The agent calls /API/2.0/MCP/external/ the connection name. That request hits the Databricks proxy. The proxy looks up the UC HTTP connection, which holds the host, the base path, and the credential, and injects the credential into the outbound request to the partner API. The partner only ever sees the token. One detail worth knowing: internal Databricks headers like authorization, cookie, and anything starting with X Databricks are stripped at the proxy. That's a deliberate guardrail so workspace credentials never leak to the third party. Within external MCP, there's a second decision to make: which authentication mode, shared principal modes, bearer token, OAuth machine to machine, or OAuth user to machine shared, are the right choice when there's no concept of an individual end user, or when the partner API is billed per workspace. DataDino's licensed museum API fits here exactly, since one identity handles every caller. Per user OAuth is different. Each end user of the agent authenticates individually, and the upstream service only returns what that specific person is allowed to see. Use it for personal data, a user's own GitHub pull requests, their own SharePoint files, so you avoid a shared, overprivileged service account. The decision rule is simple. If the scenario describes personal, per user data, shared principal is the wrong answer. That covers the two cases where Databricks does the hosting for you. Managed MCP for assets already in Unity Catalog, permissioned by UC grants. External MCP for third-party services, reached through a UC HTTP connection that holds the credential. Now for the case where you do the hosting. Custom MCP. Custom MCP is for everything else. The tool isn't in Unity Catalog, and there's no pre-built external connector for it, so you write the MCP server yourself and deploy it as a Databricks app. Once deployed, the tool's endpoint lives at https://your-app-url/mcp. Typical use cases are a proprietary internal API, a legacy system the rest of the platform can't reach, or a piece of custom business logic that doesn't naturally fit as a UC function. The docs are explicit. After deployment, you find your app URL in the Databricks UI, and the MCP server endpoint sits at that app URL with /mcp on the end. So the pattern to recognize on the exam is, any URL ending in /mcp that isn't under /API/2.0 is almost certainly a custom server hosted as a Databricks app. One small rule that catches first-time builders: your Databricks app name has to start with MCP-. If it doesn't, AI Playground won't discover it, and your agent might not either, depending on how you wire things up. It's a 5-character convention that's easy to miss in tutorials and easy to debug the moment you know it exists. Here's the part the exam loves to test. Custom MCP servers are permissioned through Databricks Apps, not Unity Catalog. You grant can_USS on the app itself. Compare that with managed MCP, where you grant select on the function or US on the index, standard UC grants. So if you see an answer choice that says grant US age on the app, ring the alarm. That's mixing two permission models that don't combine. And in production, the agent service principal must hold can_USS on that app, or every call fails. One line locks this in. Access to custom MCP servers is controlled through Databricks Apps permissions, not Unity Catalog grants, not secret scope ACLs, apps permissions. Here's the production failure mode that catches experienced teams. In development, the agent works because you, the developer, and can_USS on the custom MCP app. You deploy, and every tool call returns 403. The reason is that the deployed agent runs as a service principal, and that service principal does not have can_USUs. The engineering rule to remember is that, for app-to-app calls, can_USEs is not inheritable through a bundle resource declaration in Databricks.yml. You either grant it manually after deployment through the CLI, or you declare the app as a resource at MLflow logtime, which is a separate mechanism. Miss both, and the agent fails in production every single time. Side by side, managed MCP uses Unity Catalog grants, USE's catalog, US schema, select on the function. The permission lives on the asset, it's SQL grantable, and every check is audited inside Unity Catalog. Custom MCP is different. The permission lives on the app itself. You grant can_USS on the Databricks app, and it gets granted to a user, group, or service principal. Remember from the previous scene, uGrant can underscore USAs manually after deployment via the CLI or API, since it can't ride along as a bundle resource. Different models, different verbs, different homes, don't mix them. For managed and external MCP, Databricks holds the keys for you. For custom MCP, you hold them, which raises the question a security review will lead with: where, exactly, does that API key go? Every external service needs a credential, an API key, a bearer token, OAuth tokens. There are 3 places that credential could live. It could be hard-coded as a string in your tool function. It could stored in a Databricks secret, fetched at runtime. Or it could stored in a Unity catalog connection. Only 2 of those pass a security review, and the wrong choice is the single most common production failure for agents on Databricks. The policy from the docs is unambiguous. Credentials never go in notebooks, never go in plain text. They stored in Databricks secrets and get referenced by name. That's the rule the security scanner enforces. The analogy on the next slide is how to remember why. Here's the picture. Hard coding an API key in a notebook is like writing your ATM PIN on a sticky note and pasting it to your monitor. Anyone glancing at your screen sees it. Anyone who screenshots your notebook output sees it. A secret scope is the locked drawer. You ask the drawer for the value at the moment you need it. The value lives in memory just long enough to make the call, and it never appears in the photo you post of your desk, meaning the notebook output, the log file, or the trace. Anti-patterns on the left, an API key as a literal string, a token committed to the repo, a token printed in notebook output, a token stuffed into an environment variable visible to any process that lists env. Every one of those will fail a security review, and Databricks even ships a scanner that hunts for these exact patterns. On the right, the production correct shapes. Fetch the secret with debutils.secrets.get at call time. Use a UCHTTP connection for external MCP. The value never appears in logs or output, and the permission lives in Unity Catalog or Scope ACLs where it can be audited. The shape to memorize is 3 lines. Inside the tool function, call debutils.secrets.get with a scope name and a key name. That returns the value as a string. Build your authorization header from it, make the request, and you're done. The key never appears as a literal anywhere in your code. The scope name and the key name are the only things in the repo, and those are public information by design. 2 valid homes for the credential, and they're for slightly different jobs. Databricks secrets are workspace local, read with debutils.secrets.get, and they're the right answer for single workspace tools and the credential needs inside a custom MCP server. Think of them as the minimum bar for any external key. Unity Catalog HTTP connections are cross-workspace, governed in UC, and SQL grantable. That's what the external MCP proxy uses under the hood, and it's the modern answer when production needs to be audited across workspaces. Here's the rule to lock in. If it's external MCP, the credential goes in a Unity Catalog HTTP connection. If it's a custom MCP that needs a key, the credential goes in a Databricks secret. Hard-coded? Never. That's the entire decision tree, and it answers every credential question you'll see on this material. Now let's put all of this together with the canonical scenario, the same shape that appears on the official Databricks sample questions. DataDino is building a research agent for its curators. It needs 2 data sources. The first is the Museum Knowledge Index in Mosaic AI Vector Search, which already lives in Unity Catalog. The second is a partner museum's licensed REST API, third-party, gated by a static API key. The question splits into 2 halves. How do you wire each tool, and where does the partner's API key go? Here's the wiring that solves it. The research agent is a responses agent, the framework piece from episode 11. It points at two MCP servers. On the left, a managed MCP @/API/2.0/MCP/iSearch/DataDino/museum/museum_KB. That's the curated knowledge index, and Unity Catalog grants enforce who can read it. On the right, an external MCP for the partner museum's REST API, authenticated with a bearer token. And here's where governance pays off. The bearer token lives inside the UC HTTP connection itself, not in agent code, not fetched from a separate secret at call time. The Databricks proxy injects it on the way out. That's the whole picture: one agent, two servers, one governed credential home. The question to ask is always the same. Does Databricks already govern this asset? If yes, managed MCP. Is it a known third-party service you're calling? External MCP, with the credential in a UC HTTP connection. Is it yours to build? Custom MCP, deployed as a Databricks app, and anywhere a credential appears in any of those paths, it lives in a secret store, never in agent code. The trigger phrases in the scenario are just the surface: vector search index in our workspace, partner API with an API key. They only matter because they answer those three scenarios. Now the distractors. Building a custom MCP for the vector search index is wrong because vector search already lives in Unity Catalog. Managed MCP exists for exactly this case, and standing up a Databricks app for it is wasted work. Hard-coding the partner key fails the security review and any secret scan. Stuffing the key in an environment variable looks safer but isn't. It's visible to any process that lists env. It's not audited, and there's no rotation story. And grant usage on the Databricks app mixes two permission models. Apps use can_USE, UC uses USAge, and they don't combine. Spotting these four shapes will rule out most wrong answers on this material. One practical workflow worth knowing before we close. Before you write a line of agent code, point AI Playground at the MCP server URL. Playground Auto discovers the tool list, and you can invoke each tool by hand to see what comes back. It catches OAuth misconfigurations, missing can_USE's grants, and broken tool docstrings while you can still fix them quickly. The same flow works for all three server types: managed, external, and custom. Of all the pitfalls, the one that bites experienced teams hardest, not just beginners, is this: can_USEs on a custom MCP app is not inheritable as a bundle resource. So your dev tests pass, your bundle deploy succeeds, your security review signs off, and then production returns 403 on the first tool call. The fix is to grant can_USAs manually to the deployed service principal, or declare the app at MLflow log time. Beginners hardcode credentials and get caught immediately. This one slips past every review. One sentence before the rules. Tool access problems stored in the MCP layer. Reasoning and routing problems stored in the framework layer. That tells you where to look when something breaks. 5 rules that resolve every scenario on this material. Tool already in Unity Catalog. The answer is managed MCP third-party SaaS like Glean, GitHub, Drive, or SharePoint. The answer is external MCP routed through a UC HTTP connection. Proprietary service with no UC representation. The answer is a custom MCP deployed as a Databricks app. For credentials, external goes in a UC connection, custom goes in a Databricks secret. Hard-coded is never the answer. And for authentication mode, personal data per user means per user OAuth, while partner build APIs mean shared principal. 5 things to take with you. There are 3 MCP types: managed, external, and custom, and you pick by where the tool lives, not by what you built last time. Managed MCP URLs all live under /API/2.0/MCP and are permissioned by Unity Catalog grants. External MCP routes through AUC HTTP connection that holds the credential. Custom MCP runs as a Databricks app permissioned by can_USUs, and you declare it as a resource at log time so the deployed service principal gets access, and the credential rule that ties it all together. API keys go in Databricks secrets or UC connections, never in the agent code. Now let's see how well you absorbed all of this with a quick 5-question quiz. Alright, time to put your knowledge to the test. Question 1. A GenAI engineer is building a research agent that needs to query a Mosaic AI vector search index already registered in Unity Catalog under the schema DataDino.museum. Which MCP server type should they configure? Is it A, a custom MCP server deployed as a Databricks app with an MCP-prefix, B, an external MCP server backed by a Unity Catalog HTTP connection, C, a managed MCP server at /API/2.0/MCP/iSearch/DataDino/museum/the index name, or D, a custom MCP server with the index credentials stored in a Databricks secret. Take a moment to think about it. The answer is C. Vector search indexes already stored in Unity Catalog, so the managed MCP server fronts them automatically, zero infrastructure, zero credential handling, and UC grants enforce access on every call. The current canonical path uses the iSearch prefix. The older vector search prefix still works for backwards compatibility, but new work should use iSearch. Choosing custom or external for an asset that's already in UC means standing up plumbing that Databricks has already built for you. Question 2. A research agent needs to call a partner museum's license REST API, authenticated with a static bearer token. The team must pass a security review before deployment. Where should the bearer token live, and how should the agent reach the API? A. Hardcode the token in the tool function for simplicity, and wrap the call as a custom MCP server. B. Store the token as a literal in an environment variable, and call the API directly from the agent. C. Configure an external MCP server backed by a Unity Catalog HTTP connection that holds the bearer token. Or D. Create a custom MCP server and grant USAge on it to the agent's service principal. Take a moment to think about it. The answer is C. External MCP with AUC HTTP connection is the production correct pattern. The credential lives in governed Unity Catalog, Databricks injects it at the proxy boundary, and your agent code never sees the token. Hard coding and environment variables fail any secret scan, and grant USAge mixes the UC permission model with apps, which use can _USE instead. Question 3. A team built and deployed a custom MCP server as a Databricks app for their proprietary pricing engine. The agent works in development, but every tool call returns a 403 forbidden in production. What is the most likely cause? A. The app name is missing the MCP-prefix required by AI Playground. B. The Databricks app was not declared as a resource when the agent was logged with MLflow, so the deployed service principal does not have can_USEs. C. The custom MCP endpoint should be hosted at /API/2.0/MCP/custom/ rather than at the app URL. Or D. Custom MCP servers require a Unity Catalog HTTP connection, which was not configured. Take a moment to think about it. The answer is B. In development, you have can_USEs on the app yourself, so everything works. The deployed agent runs as a different identity, a service principal, and it only inherits can_USEs when the MCP server is declared as a resource during ML flow log time. Skip that declaration and production fails on every tool call. The MCP-prefix matters for AI playground discovery, not for runtime authorization. Question 4. An engineering team wants to build an agent that lets each developer query the GitHub pull requests they personally have access to. No shared service account, no overprivileged token. Which authentication mode should the external MCP server use? A. A shared bearer token stored in a Databricks secret. B. OAuth machine-to-machine using a workspace-level service principal. C. Per-user OAuth, that is U2M per user, so each developer authenticates individually. Or D. A hard-coded GitHub personal access token in the agent's tool function. Take a moment to think about it. The answer is C. The scenario specifies personal data. Each developer should only see their own pull requests, so per-user OAuth is the right mode. Each user triggers their own OAuth flow on first use, and GitHub returns exactly what that individual can access. Shared principal modes collapse everyone into one identity, which is wrong when the upstream service has its own per-user permission model. Question 5. A team builds a custom MCP server as a Databricks app to wrap a partner REST API. The agent works for the developer locally, passes integration tests, and deploys cleanly. In production, every tool call returns 403. What is the most likely cause? A. The custom MCP app was named without the MCP-prefix, so AI Playground cannot discover it. B. The deployed agent's service principal lacks can_USS on the app, and can_USS is not inheritable through a bundle resource declaration. C. The partner API key was stored in a Databricks secret instead of a Unity Catalog HTTP connection. Or D. Custom MCP servers cannot be called from agents deployed to model serving. Take a moment to think about it. The answer is B. The signature of this bug is that everything passes until production. The developer has can_USS on the app, but the deployed agent runs as a service principal that does not, and can_USEs for app-to-app access is not inheritable through a bundle resource declaration in Databricks.yml. You either grant it manually after deployment or declare the app at ML flow log time. The MCP-prefix only affects discovery in AI Playground. Secrets are perfectly valid for credential storage, and custom MCP servers can absolutely be called from model serving. That wraps up MCP servers, managed, external, and custom integration. The Databricks GenAI Engineer Cert has more videos coming on the trickier topics. Subscribe so the algorithm tells you when. Thanks for watching.